Hi everyone, this is a video for the Pre-Al 5.3 to 5.5 review. So I'm going to jump right in. This entire first page, or I guess these first four examples, are all going to be substitution. So for all of these, I'm using substitution. This very first one, I have y equals x plus 3 and y equals 4x minus 6. Both of those equations equal y. They equal the same thing. This equals y, and this equals y. Since they both equal y, they also equal each other. Another way to think of it as, just think of it as normal substitution. I could take this and plug it in here. You're plugging in what y is to y in the other equation. So I would write that as x plus 3 equals 4x minus 6. And I'll keep the highlight so you can see where it went. Now, since I have variables on each side of the equal sign, I have to start by moving over the lesser variable. I'm going to subtract x from both sides, and I will get 3 equals 3x minus 6. Now I want to move the constant to the other side, so I have my variable on one side and constant on the other. So I'm going to add 6 to the right, add 6 to the left, and I will get 9 equals 3x. Then my last step is I have to divide out the coefficient. So I divide by 3, and I will get x equals 3. I have one variable, but I have to find the other. So then you choose one of the equations to plug it back into. They have to have both variables. I'm just going to do the top one because it'll be a little faster. So I have y equals x plus 3, and I'm plugging in 3 for x. So I'm going to put y equals 3 plus 3, which will give me y equals 6. And then last step is you write it as an ordered pair, x comma y. So my solution is 3 comma 6. Now we're going to move on to the next one. You start by circling what is given to you. Y is given to me, so I'm going to circle it or square it, and then I have to plug it back in to the same variable in the other equation. So I'm plugging in for y, or you can plug in x for x, but you cannot switch them up or it will not work. So now I am going to rewrite this equation, but instead of y, I'm going to write what we substituted it for. So I have x plus, then in parentheses, 2x plus 4 equals 7. Then I can just drop those parentheses. X plus 2x, those are like terms. That will give me 3x plus 4 equals 7. Then I can subtract 4 from both sides. Again, the goal is to get x by itself, your variable by itself. That cancels out. I get 3x equals 3. Now that my constants are on the right side, I can divide by the coefficient. So I divide by 3, and I get x equals 1. Now I'm able to plug in the variable we just found into one of the equations to solve for y, the other variable. Doesn't matter which one you choose as long as they have both variables. I'm going to do the top one. So I have x plus y equals 7. Then I'm going to rewrite it with 1 instead of x, because 1 is x, plus y equals 7. I want to subtract 1, and I will get y equals 6. So if I write that as an ordered pair, my solution is 1 comma 6. Now I'm going to start down here, same idea. I'm going to circle what is given to me, so I have y equals, then I plug it in to y in the other equation. This is the equation I'm going to rewrite, the one that was just substituted into. So I have x minus 3, then in parentheses, 2x plus 9 equals negative 12. I want to use distributive property, so I still have my x, but negative 3, this entire thing, it's negative 3 times all of it. Since it's being subtracted, it's negative 3 times 2x, which will give me negative 6x. Then negative 3 times 9 will give me negative 27. So minus 27. Then lastly, equals negative 12. I am able to combine like terms. X minus 6x will give me negative 5x. Then I still have my minus 27 equals negative 12. Now, since I have my variable on one side, I want to move my constant to the other side. I am going to add 27 to the left, add 27 to the right, and I will get negative 5x equals 15. And then my last step is you divide by the coefficient, which will give me x equals negative 3. Now I have to substitute x, which is negative 3, back into one of the equations. I'm going to do the bottom one. Again, it doesn't matter which one, as long as they have both variables. So y equals 2x plus 9. But now I'm going to plug in negative 3 for x. So I get y equals negative 6 plus 9, y equals 3. So that means my solution is negative 3, comma 3. All right. Next one, same thing, circle what is given to you, and you plug it into the same variable in the other equation. I plug in y for y, and the equation that is being substituted into is the one that we're going to work with. So I'm going to write 2x minus 4, then in parentheses is 2x plus 2 equals negative 32. I still have my 2x, but I have negative 4 times 2x, which is going to give me negative 8x. Then negative 4 times 2 will give me minus 8 equals negative 32. I can combine like terms. So 2x minus 8x will give me negative 6x minus 8 equals negative 32. Then I'm able to move my constant over to the other side. So I want to add 8 to both sides, and I will get negative 6x equals negative 24. Then my last step is I divide by the coefficient, which will give me x equals 4. Then my final step is I have to plug it back in to one of my equations to solve for y. I'm going to just choose the top one. So I have y equals 2x plus 2. Y equals 2 times 4, because x is 4, plus 2. Y equals 8 plus 2, so that means y equals 10. And my ordered pair will be 4, comma 10. Okay, that was all solution. That was all substitution. Now this right here is all going to be elimination. My first step is to see which variable is going to be eliminated. I have a 3 and an 8. Again, we're not looking at the signs right now. Different numbers, can't eliminate x. I have 2y and 2y, so that is what will be eliminated. Since they have different signs, one's being added, one is being subtracted, that is when you add. Different signs equals add. Same signs, whether it be both positive or both negative, is when you have to subtract. So I have negative 3x plus 8x, which is going to give me 5x. Then I have 2y minus 2y, which is going to give me 0y. We can just cross that out, equals 0. Then negative 18 plus 28 is going to give me 10. So 5x equals 10. Then I want to divide by the coefficient, divide by 5, and I get x equals 2. So we found x by eliminating y. Now I have to choose one of the equations to plug x back into. I'm just going to use the top one. So I have negative 3x plus 2y equals negative 18. Negative 3 times 2 plus 2y equals negative 18. Negative 6 plus 2y equals negative 18. So now I'm able to start isolating y. I want to add the constant to the other side. So add 6, and I get 2y equals, give me 1 second, okay, negative 12. Now I can divide by the coefficient, divide by 2, y equals negative 6. That means my ordered pair, my solution is 2, negative 6. Next one. I have 3x and 2x. I am not going to be eliminating that. There's no way I can add or subtract those two to get 0x. I have y and y. I can eliminate that. One subtracting, the other is subtracting. Same sign equals subtracting. If I do negative y plus negative y, I get negative 2y. However, if I do negative y minus negative y, when you subtract a negative, it just becomes a big plus sign and I add it. So I want to subtract that bottom equation. But when I do that, every term on the bottom switches signs. Positive 2x becomes negative 2x. Negative y becomes plus y. Positive 3 becomes negative 3. We just divided that entire bottom equation by negative 1. Now that we did that, I can combine it. So 3x minus 2x will give me x. Negative y plus y will give me plus 0y. I can just cross that out. Then lastly, 2 minus 3 equals negative 1. So that means I have x equals negative 1. First variable is done. Now I have to substitute it back in for one of the equations. It has to be the original one, not after you multiply it by negative 1. I'm just going to use the top one. 3 times negative 1, because that's x, minus y equals 2. Negative 3 minus y equals 2. Now I'm able to solve for y by isolating it. I want to start by moving over the constant. And I have negative y equals 5. Then I have to divide out that negative. So when I divide by negative 1, I get y equals negative 5. And my ordered pair is negative 1, negative 5. Okay. Next one, I have x and 2x. I am not going to eliminate my x. I have y and y. One's being added, the other's being added. Same sign equals subtract. If I do y plus y, I get 2y. The goal is to get 0y. You have to eliminate it. So I have to subtract. So that means every sign on the bottom switches signs, or I'm sorry, every term on the bottom switches signs. My negative 2x becomes plus 2x. My plus y becomes minus y, or negative y. Then my negative 2 becomes plus 2. Now I can start combining. X plus 2x is 3x. Y minus y is plus 0y. I can just eliminate that. 4 plus 2 equals 6. Now I am able to divide by the coefficient, so I can solve for x. Divide by 3, divide by 3, x equals 2. Now I want to plug that in into one of my original equations. I'm just going to use the top one. I'm going to put 2 plus y equals 4. Again, we got that from that top equation. Now I'm able to subtract the constant because I want to find what y equals. And then I get y equals 2. So I write that as an ordered pair, 2, 2. All right, moving on. Again, I want to find the term first. Then I look at the signs of it to tell me if I add or subtract. 7x and 7x. I can eliminate that. 8y, 10y, I cannot. So I know I'm eliminating x. One is negative, one is positive. Different signs tells me I add. So I do not change anything with that bottom equation. Negative 7x plus 7x will give me 0x. That cancels out. Negative 8y plus 10y will give me 2y. Then negative 19 plus 29 will give me 10. Now I can divide by the coefficient, which is 2, to solve for y, and I get y equals 5. Now I want to plug that back into one of the original equations. I'm just going to use the top one. So negative 7x minus 8 times 5 equals negative 19. Negative 7x minus 40 equals negative 19. Then I want to add 40, and negative 19 plus 40 is, give me one second, 21. So now I have negative 7x equals 21. Divide by negative 7, divide by negative 7, x equals negative 3. That way I can write it as an ordered pair of negative 3, 5. That is elimination. Now we're going to look at some word problems. These are going to be elimination word problems, but we don't have to solve them. A group of people bought movie tickets. They bought a total of 7 tickets. Some of them were adult, some of them are children. They spent a total of $72. The adult tickets were 12. The children's tickets were 9. I want to write a system of linear equations to represent this situation. So I basically want to see how many of each the adult tickets and the children's tickets were sold. What I want to find is going to be my variable. I can say that A equals adult ticket sold. Because again, we don't know that, because this whole idea is we're solving for the variables. Then C equals child's tickets sold. That's what we're wanting to find. So, bought. Yeah, tickets bought. Same thing. So, if there was a total of 7 tickets bought, some were adults, some were children, and we don't know how much is each, I can say the amount of adult tickets bought plus the amount of child's tickets bought equals 7. I get this from right here. That's my first equation. Then, if I know the adult tickets are $12, I can write 12A. The child's tickets are $9, so plus 9C equals, and the total cost was $72. That is what I got right here. So this is our systems of equations. And again, you do not have to sell it. Do not have to solve it, sorry. All right, next one. There are 13 animals in Fred's barn. Some are chickens, some are pigs. There's 40 legs in all, and I want to write a system of linear equations that represents this situation. So, if I know there's 13 animals total, they're either pigs or chickens, I want to see how many of each animal there is. That's what I'm looking for. So I can say C equals number of chickens, because again, we don't know that. That's what we're looking for. Then P equals number of pigs. So if there's 13 animals in total, and they're made up of chickens and pigs, then I can say that the number of chickens plus the number of pigs equals 13. And I get this from right here. That is our first equation. Now I know that there's 40 legs in total. So that means the legs of the chicken and the legs of the pigs add up to 40. Now it doesn't tell you this, but think. A chicken has 2 legs, so 2 legs per chicken. A pig has 4 legs, 4 legs per pig. And in total there's 40 legs, so equals 40. And I got this from right here. That's our second linear equation. That's our systems of equations. Okay, next up, Chase and Sarah went to the candy store. Chase bought 5 pieces of fudge and 3 pieces of bubble gum for a total of $5.70. This right here, I can highlight, that's its own separate event. So that's going to be its own linear equation. Then Sarah bought 2 pieces of fudge, 10 pieces of bubble gum for a total of $3.60. This is a separate event in a separate equation. Then I want to write a system of linear equations that represents this. And again, you do not have to solve. So I know how many of each for the fudge and the gum was bought. I want to find out how much they cost. That's what we don't know. So I can say F equals cost of fudge, because again, we don't know that. And then B equals cost of gum or bubble gum. So if Chase bought 5 pieces of fudge, there's 5 of them. I don't know how much they cost, but F is what the price per fudge costs. So I'm going to put 5F plus 3B equals 570. That is my first equation that we got from right here. Then I want to put my second one. Sarah bought 2 pieces of fudge and 10 pieces of gum, which costed $3.60. And that's that. And again, we do not have to solve it. All right. Last one. Ava's family drove to Disneyland for spring break. Her mom and dad shared the driving duties for a total of 24 hours. Her mom drove 75 miles per hour. Dad drove 60 miles per hour, but they drove a total of 1710 miles. I don't know why I read it like that. 1,710 miles. Write a system of linear equations that represents this situation. Okay, so what I'm looking for is how many hours did mom drive, how many hours did dad drive. I know how many miles they went total, I know how many hours it was total, and I know the miles per hour, but I don't know how many hours they each drove. So let's say M equals number hours mom drove. then I can say D equals number hours Dad drove. So this is what we want to find. This is what we don't know. So if I know that Mom and Dad shared the driving duties for 24 hours total, then I can say the hours Mom drove plus the hours Dad drove equals 24, and I get that from right here. That's my first equation. Her mom drove 75 miles per hour, so I can put 75 here. And her dad drove 60 miles per hour, so plus 60 here, and it was a total of 1,710 miles. And we got that all from right here. Okay, so that is elimination. Now we're going to move on to special solutions, and this is when we have to see, am I going to use substitution or elimination? Now, I'm going to use substitution if one of the variables is given to me, one or both. That means y equals ... or x equals ... Since I'm given y equals negative 2x plus 6, I'm going to substitute it for y in the other equation. So I'm going to rewrite that top equation as 2x plus, then in parentheses, negative 2x plus 6 equals 7. Now I'm able to just drop these parentheses. I don't have to distribute anything. 2x plus negative 2x, that is 0x, or 0. So now I have 0x plus 6 equals 7. 0x equals 0. I can eliminate that. Then I have 6 equals 7. 6 does not equal 7. Because of that, it is no solution. It's a false statement. All right, next one. So I do not have y equals ... or x equals ... I have both equations in standard form, meaning something x plus something y equals something. They both are in this form, so I have to use elimination. So I have 2x, 2x. I can eliminate x. I have 16y, 16y. I can eliminate y. So how does that work? I'm just going to choose one of them. If I have 2x and 2x and they're both opposite signs, different signs equals add. Same signs equals subtract. I am going to add these. I'm going to combine it. Negative 2x plus 2x is 0x. This gets eliminated. That equals 0. 16y plus negative 16y is plus 0y. This gets eliminated. That means the only thing on the left side is 0. Then negative 34 plus 34 is 0. Oh my gosh, 0 equals 0. That is a true statement. That means infinite, many solutions. If it's a true statement, it's infinite. If it's a false statement, it's none. Or no. All right, so we are given something. I have y equals 4x plus 6. Since I was given a variable, that is when I'm going to use substitution and plug it in to the other equation in the same variable. So this is the equation I want to rewrite. I have 2 times 4x plus 6 equals 8x plus 12. We just plugged that in. Now I have to do distributive property. 2 times 4x is 8x. 2 times 6 is plus 12, then equals 8x plus 12. Now you can see I have the exact same thing on the left side and on the right side. It's the exact same thing. So I can stop right here and say I have infinitely many solutions. If you're wondering, how does that work? Let's say I wanted to start by moving my variable first. Minus 8x minus 8x. Then I have 12 equals 12. Now you can see that it's infinitely many solutions. All right, and our very last one, I have a variable being given to me. I have y equals and y equals. If I know that y equals 15x plus 1, but it also equals 15x plus 2, then that means that 15x plus 1 equals 15x plus 2. Okay, let's try solving for x. I'm going to start by subtracting 15x from both sides. That cancels out, and I get 1 equals 2. 1 does not equal 2. That is a false statement, so that means no solution.